Could an engine that is not perfect but simply more efficient than a reversible engine exist? And what we mean by a reversible engine is one that is comprised of time reversible processes. It's worth recognizing that we're not talking about a practical engine where it can run in the forward direction and behave like a real engine, then you pull a lever and now it's behaving like a refrigerator, because probably if we built a real device that would do that for just whatever reason, just because we want to show that we could, chances are the efficiencies would not really be the same in both directions. Whereas if it were truly comprised or based upon time reversible processes, that would be the case. So it's good to recognize that we're talking about something that's really theoretical here. But the implication is if it really is true that an engine that is not perfect, but simply more efficient than a reversible engine, if that cannot exist, that means that the reversible engine really represents an upper limit to efficiency. So let's look at this picture I've drawn here on the whiteboard to see how that might be the case. This engine here, represented by this circle with the letter R in it, is meant to be my reversible engine. It's being driven by a more efficient engine. To see why that might be, let's look at what the efficiencies are for these two engines. Now, the reversible engine is a little bit hard to look at here because it is being driven in reverse. But if you thought about what it would look like driven in the forward direction, and we're going to assume that all of these arrows represent an equal flow of energy. In the forward direction, these arrows would point down rather than up, these ones up here. There would be 3 arrows input to the reversible engine in the forward direction for 1 arrow as output work, because this flow right here definitely represents work. That would mean that there would be an efficiency there of 1/3, which is equal to about 33.3%. This engine over here that I've claimed is more efficient, we can see that because for 2 arrows input, there is 1 arrow of output work. So that implies an efficiency of 1/2, which is equal to 50% more efficient than the pictured reversible engine. Put together, though, these two are violating the second law of thermodynamics, because as a system together, there is no input of external work. They're exchanging work between each other, but if the combined system is considered, that is internal work. That is not an external source of work. And yet, nevertheless, this picture is showing a flow of heat from the cold region to the hot region, which the second law of thermodynamics clearly states is only possible if external work is supplied, which this picture again does not show. So therefore, the answer to this is this type of an engine could not exist. And moreover, that means if you look at the efficiency of a hypothetically existing time reversible engine, that really is going to be the upper limit of efficiency. So let's look at the answer here. It says no, such an engine driving the theoretical time reversible engine would also lead to heat flowing from cold to hot temperature without the external input of work, which is that statement of, or a violation of the statement of the second law of thermodynamics that we have been referencing.